the arrangement of the atom. We're going to do a couple review items first. We know that the periods go horizontally, they go across, and that the groups are vertical. And we know that elements in the same family or the same group have similar physical and chemical characteristics. We know that the periodic table has the atomic number, symbol, the name, and the atomic mass. And we also know that the atom is the smallest part of an element that has all the elements, all of the properties of an element. Each element has its own unique kind of atom, and the atoms of different elements have different masses, different volumes, and different reactivity. Continuing on with the review, as of right now, there isn't anything that you need to write, but you will complete your notes on page 17 in your ISN. We know that atoms are not the smallest part of matter, but they're subatomic particles called the protons, the neutrons, and the electrons. We know that protons have a positive charge, electrons a negative charge, and neutrons have a neutral charge, no charge at all. So, to quickly recap summary, protons positive, neutrons are neutral, electrons are negative. The protons and neutrons have a mass of 1, and electrons' mass is negligible. So where are they located? We know that the protons and the neutrons are in the nucleus of the atom, and that the protons and neutrons are held together by strong forces. The number of protons in an atom is known as the atomic number, which is also the number of electrons, which we'll get to in a moment. Each atom has a unique number of protons, and thus each atom has a different atomic number. We also know that the periodic table is set up based on the atomic number of the element. So to formulate the mass number, let's go back for a moment. We learned about ape, which is the atomic number is the same as the number of protons, which is the same as the number of electrons. Now the mass number. Together the protons and the neutrons make up the mass of the atom, and the mass number is the sum of the protons and the neutrons, or the acronym that we learned, MAN. The mass minus the atomic number equals the neutrons. All right, so now this is where you need to start taking your notes. What's inside the electron cloud? So surrounding the nucleus are a series of electron-like energy levels called shells. The shells are what we're going to talk about. So surrounding the nucleus, there are energy levels called shells. These shells are occupied by electrons. So the electrons are in the shell of the atom. And it's about 1,000 times larger than the nucleus itself. So think of it like this. If the nucleus was the size of a golf ball, then the first electron shell would be about 1 kilometer away. The second electron shell would be about 4 kilometers away, and the third electron shell would be about 9 kilometers away. So it's a pretty big area. So again, the protons and the neutrons are in the nucleus, where the electrons are in the shells. When the number of electrons equal the number of protons, then the atom is considered to be neutral. This is what you need to highlight in this area. When the number of electrons equals the number of protons, the atom is neutral. It has no charge. And we'll talk about electrical charges in a moment. When there are more electrons, electrons are negative, then there are protons, then the charge is negative because there's more negatives. When there are less electrons than protons, then the charge is positive because the protons take over. So the protons make the entire atom's charge positive. If there's more electrons, it makes the entire atom's charge negative. Stop, rewind if you need to. So what influences each subatomic particle? The mass and the charge influences the protons. Only the mass influences the neutrons, and only the charge influences the electron. So now we're going to talk about creating a Bohr model of the atom. The electrons surround the nucleus in the shells, which we just talked about, and each shell has a specific energy level. You need to go ahead and write Bohr model. This should be another bullet. Each shell has a specific energy level. The innermost shell can hold a maximum of 2 electrons, and then the next 2 shells can hold a maximum of 8 electrons. The outermost shell is called the outer shell. Now, attic in your textbooks only label it as outer shell, but in the rest of the world we call it the valence shell. So I've included both, the outer valence shell. So the electrons in the valence shell are called valence electrons. Very simple. It's in the valence shell. They're called valence electrons. So you can look at this diagram. These are the shells. So this is the outermost shell, which is the outside of the atom. They're the outer shell. And the electrons that are in this shell are called the valence electrons. Then we have the middle shell and the innermost shell. The first shell can only hold a maximum of 2. The second shell can hold a maximum of 8. And the outermost shell, which in our case for sulfur, there's only 3 shells, can hold a maximum of 8 as well. So, to create a Bohr diagram, it's an illustration of an atom that holds the arrangement and the number of electrons in each shell. And my time is going, so I need to speak quickly. So, a Bohr diagram is an illustration of an atom which shows the arrangement of electrons in each shell. So let's take a look at this example. We have sulfur. To get the information from the periodic table, and so you can draw the sulfur Bohr model. You know the atomic number, which is the same as the number of protons, which is the same as the number of electrons if it's in a neutral atom. So for our purposes, it's 16. This is the atomic number, 16. The atomic mass, we round to the nearest whole number. You know, you look at this 0, and which makes this number stay. So the mass is 32. So in order to create a Bohr diagram, you place the symbol of the element in the center, and you pair your electrons up if you have more than 4. And you keep counting for a maximum number of electrons for each shell. So the first shell again can hold 2 electrons, and the next shell can hold 8 electrons. So here's a diagram. The first shell has this 1 electron and this 1 electron. We have 2 electrons. The second shell has the 8 electrons. Then the third shell only has 6 because sulfur only has 16. So 2 plus 8 plus 6 equals an atomic number of 6, which is also the total number of electrons. Now, we also need to know how to write this. We also need to know how to write this as an electron arrangement. So your next bullet needs to say electron arrangement. The electron arrangement, you just simply write the numbers for each shell. So 2.8.6. 2, 8, 6. 2 in the first shell, 8 in the second shell, 6 in the third shell. Now, if you were only given these 3 numbers, you should be able to tell me which element it is, because you know there's only 2 in the first shell, 8 in the second shell, 6 in the last shell, a total of 16 electrons. You go to the periodic table, you find the atomic number of 16 because you know there's the atomic number is the same as the number of electrons. So take a break, take a minute and look at the first 20 elements. And if you're up to it, go ahead and create a Bohr diagram of the first 20 elements and write the electron arrangement. It's not necessary, I will not collect it, but this is just to help you so that you understand how to create the Bohr diagram as well as the electron arrangement. The next we have a Lewis dot diagram. This is very simple. The Lewis dot diagram is a drawing of an atom with only its valence electrons. So it's only the electrons in its outer shell. Carbon, the atomic number for carbon is 6. So that means that there's 2 in its first shell and 4 in its outer shell. They only have 2 shells. Its arrangement would be 2.4. All right, if an atom has a full valence shell, no electrons are needed and thus only the element symbol is used. So if the electron is completely full, like helium has an atomic number of 2, which means 2 electrons. So there's nothing that needs to be written. It's only He because it is finished. All right, quickly, let's talk about some different trends in the periodic table. So do you see any trends with the electrons in each group? Yes, this is what you need to write. All atoms of elements in the same group have the same number of valence electrons. As the group numbers increase, so do the number of valence electrons. So group 1 elements have 1 valence electron. If you see, all of the last shell only has 1 electron. Group 17, again, they all have the same number, 7 valence electrons. So what trends do you see in the numbers for the period? All atoms in the same period have the same number of shells. As the period number increases, so do the number of shells. So you can see here that the second period has 2 electron shells. The third period, period 1, period 2, period 3, has 3 electron shells. That's all, guys. If you show me your ISN with these notes by Monday, I will be